All right, so welcome back to the Civil FE exam review. Today in this video, we're going to be continuing our review in geotechnical engineering, and we're going to be focusing specifically on shear strength. And so I have a few practice problems for you all today that should, enhance your knowledge on the different types of stresses and how that relates to the shear strength in soil samples. So let's go ahead and dive into the practice problems. Okay, so number one says the normal stress of a soil sample was 180 kilopascals. Based on the following information, what is the soil shear strength? So we have cohesion, we have friction angle, we have the normal stress, which has already been stated. Okay, so given every time I go through a problem, I write out the given data and then what I'm trying to find. So I'm given cohesion. I'm given this friction angle. I'm also given normal stress. And I'm trying to find shear strength. So what formulas might I need? So formulas that may be dealing with the normal stress of a soil, cohesion of a soil, friction angle of a soil, I'm assuming. So maybe if I do cohesion, sounds like a word that might not, that I can search, that may be, there might not be a lot on it. So there's only two matches for cohesion. So let's see what comes up. Okay, so cohesion and cohesion. So one for ultimate bearing capacity, which you need different. We're not searching for any bearing capacities, or we don't have any factors for those. So the only one was the first one, which cohesion, showing that cohesion equals C. And then we notice that we're in the geotech section, and we have this T sub F. And that T sub F is going to be your shear stress at failure. And so that allows you to know what your shear strength is at whenever it fails, right? So C is equal to your cohesion. What's the sigma N? Sigma N is the total normal stress of the particular soil, or P over A, right? But we're given that, right? We are given the normal stress of the soil twice, so that we wouldn't forget, okay? And then our only other variable is phi, which is the angle of internal friction. Do we have that? I believe we do. Here. Okay, so I believe we have everything that we need to be able to solve this. Let's go ahead and write this out. So you have T sub F, the shear stress at failure, is equal to C plus the normal stress times tangent of phi, which is the internal angle. All right, so just write these out. C is equal to 25 kPa. Sometimes writing out my variables and then beside it writing out the values helps me to plug and chug a lot faster. So the normal stress is 180 kPa. What is kPa? It's a kilopascal, right? What about phi? Phi is equal to 35 degrees. All right, so let's plug and chug these numbers in. So I'm solving for T sub F is equal to 25 kPa plus 180 kPa, right, times the tangent of 35 degrees. Okay. T sub F is equal to, when I solve for this, I get 151.03 kPa. Cool. So I know my answer is B. Pretty straightforward once you understand what's happening. All right, this one says, number 2 says, the normal stress of a sand sample is 150 kPa. What is the cohesion value of the sample? All right, so we're given the normal stress. We're also told that it's sand. And they want us to find the cohesion of sand. All right. And so is there any formulas needed? Well, if we have the normal stress, all right, we don't have, we're looking for C. So C, we would need the shear stress or area of some sort, something. All right, we would need a P over A or something. So there's no formulas that are needed. You need prior knowledge for this. Just always remember that for sand, there's never cohesion. Sand has, like, if you have a sand sample, it's always going to be 0 cohesion for sand. So the answer for this question would be A. Something that you just need to remember. They may ask you on the test, and you definitely want to remember that. All right, number 3. The shear stress of a soil sample at failure is 40 kPa. What would the angle of internal friction be using the following data? So you got cohesion is 15 kPa and normal stress is 120 kPa or kilopascals. Okay, so based off the given information, all right, we are given cohesion, we are given shear at failure. Shouldn't just say shear, it should be shear stress at failure. And then we're also given the normal stress of the soil. And we're also given that it is a soil sample. All right, and we're trying to find the angle of internal friction. All right, so what formulas might we need? Well, they give us shear stress, soil sample at failure. So let's just search the internal friction. That's what we're trying to find, right? So there's only one option comes up once I search. Be here, so that phi is represented by the angle of internal friction. Okay, so I see phi right up above. So what is this? This is the shear stress at failure. Are we given the shear stress at failure? Yes. So that is here. All right. Okay. Are we given the cohesion? Yes. 15 kilopascals. Are we given normal stress? Yes. And so now we just need to get to phi. All right. Let's write this out. T F is equal to C plus It's the formula that we need. Normal stress times tan of the angle of internal friction. Okay, so we're given that this is 40 kPa is equal to 15 kPa, just C, okay, plus, what's my normal stress? 120 kPa times the tangent of theta, not tangent of theta, tangent of phi. All right. Now, once we solve, we would do 40 minus 15 divided by 120 all over the tan inverse of 1 is equal to phi. So 11.8 degrees. Make sure your units are in degrees, or your calculator is in degrees and not in radians. I'm going to get 11.8 degrees. So A. Perfect. So hopefully that made some sense. This concludes the shear strength section of the Civil FE exam review. In the next section for Geotech, we're going to be looking at bearing capacity.